Hey everybody, this is Larry, this is me going Q2 of the bi-weekly contest 148. Minimum cost to make arrays identical. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Yeah, I mean I think this one, it's, I actually, if you watch the live portion, I talk about this during the reading of this, is that sometimes they do things to try to trick you. And here, you want to split an array into any contiguous subarray and rearrange them in any order, right? Well, it turns out that the way that you would always want to do this is just once, right? Because, well, would you ever want to do it twice? No, because if you do it twice, that means you can do it once in the first time, because you can just have every subarray, or like every subarray would have element of 1, and then you just rearrange them, and then, you know, that's it. So this is just purely designed to confuse you. You only do this once, and then the rest is just this one, which is the delta between the elements, right? So the first thing is that, okay, well, if you don't use this, then what happens? If you don't use this, then you just give it, and I still find it amusing that it's array and b-ray. Anyway, yeah, then you just kind of, then you have to do element by element, because you know, and there's no, if you don't use this, there's no decision to be made, right? Because you have no choice. You just go for element by element, and then you get a cost. So what if you do this once? Well, if you do this once, there are a couple of ways you can think it, but the way that you would want to think about it is to kind of match it with something that gives you the best result. And of course, in this case, this is just you know, and the proof isn't super easy per se. It is intuitive, but it's just matching the smallest with the smallest, and then you just kind of induction from there. And I'm not going to do it in this video because, I don't know, maybe I'm just being lazy today, honestly. But it is a good practice to use the greedy, it is greedy, and as a result, it is a good practice to use the exchange argument on this problem. Again, I'll leave it up to a little bit of like homework for you to do it. I promise you it's not so bad, it's okay. Let me know in the comments if maybe next time I should do it, but no, I mean, yeah. And as a result, then you realize that, well, you're always just getting a min 2, then all you can do is put them in a heap or just sort them, as I did. And that's pretty much it. So you have cost 1, where basically you line them up, there's no choice, just kind of do the cost, right? And then 2 is if you sort both of them, and then the cost starts at k plus all the deltas, and then you just take the min of the 2 items, and that's it. So what's the complexity here, right? Well, you're going to be dominated by the 2 sorting things, so it's going to be n log n no matter what. All of n space if you want to count the linear space from the sorting, otherwise all of 1 extra, and that's it. The hard part is on the proof on the greedy, which I'm going to leave it for you to do at home. I do this on a lot of my videos, but so today, I don't know, I'll try something new. Let me know in the comments. But yeah, it's not that bad. This one's easy to prove relatively. Google up exchange argument. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live during the contest next. 3 and 5, right? Yeah, okay. All right. Don't get ahead of yourself, Larry. Calm down. But that was pretty nice. All right. In an integer k. This is the most I don't know, I just find it amusing. Let's have an array or for array and for array, I suppose. Alright, focus. I need to focus, but that is just silly. Okay. And kind of hilarious. Okay. I think I amuse myself too much. Luckily, this is a virtual, so it's not that serious. I mean, I try to take it mostly seriously, but you know, still I try to have fun, you know? Okay, anyway, you can perform the operation in an array any number of times. Any number of contiguous okay, a way to make it equal to b-way. Okay, contiguous subarray, and rearrange those subarrays in any order. This operation has a fixed cost of k. What is k? Oh, okay, so that's how it's relative. Add any element in array. Okay. What are the okay, so the numbers are big. The k is big. What is k again? Oh, the k is the fixed cost that they tell you. And the length of the arrays are big. Okay. Any number of contiguous subarrays. I don't get it. Wouldn't you just do it once? Like, I don't get what the... Like, I hate when they... I mean, it is what it is. Maybe it's just a pet peeve. It's when they have, like, fake choices, when you only ever want to do this once, because then now everything would be matched in, like, a perfectly matched kind of way, right? Alright, so that means there's only two cases. One is if you don't do that, and the other is if you do it. And if you do it, then you just sort, and okay, yeah, sounds about right. Okay, so then naming things is so hard. Whatever, just call it cost. Cost is 0, 0, right? So for x, y, and z, right? Oh, add or subtract the value to it. Okay, so that's fine. So that's cost 1. I just got cost 1 there. Right? Okay, and then the other one is array.sort, array.sort for x, y, and z, right? Cost 2 is equal to k. And you could probably have written this with a helper, but whatever. I mean, I'm already done just even talking about it. Absolute. What am I writing? I think in my head I'm just like blazing through this too fast. Am I good? Negative numbers don't matter. Yeah. Okay. Yeah. Okay. Yeah, that wasn't that bad. Alright. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, my explanation, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later. Take care. Bye-bye.